Okay, here we are. In this video, I will show you the electron gun I'm using for my scanning electron microscope project. So, the electron gun is basically looking at this. In the normal operation, the gun assembly is actually mounted in an aluminum tube. It's a high vacuum chamber, a part of a high vacuum chamber. Under this side, I'm using an acrylic tube to show you the normal operation. Under this side, there's a sample chamber, so we take it off and pull it out. This is a gun assembly. On top of this, there's a whole bunch of electrical connection, and of course they are high vacuum sealed and high voltage insulated. It's ceramic. Maybe a couple of a couple of thousand volts. This 4 BNC connector is actually using for the electron deflection electrode. So this is a pretty old design of an electron gun. In normal operation, it's basically using like an old CRT, or maybe you are seeing this in a pretty old oscilloscope. It's the same, but it's much bigger. It's using electrical field to make the electron beam deflected in the way, so it can produce a scan pattern, so can be using to scan the sample. In the middle of this, we can see the filament or the cathode. Here I have a gun assembly being taken apart. So under this, there's basically a high vacuum seal and the electrical connection and the high voltage insulation. It's being screwed on this stainless steel wire to make an electrical connection between the connector and the real part. So now we are looking at the filament assembly. This is actually not only the filament assembly. This is containing the win-out hole or the grid. So you will see it in here, the grid. Okay. So now we will take the screw out and we will see it. By the way, I will mention it. All of the screw is made of stainless steel, so it's not magnetic, so it can affect the electron pass through. So here is a insulator. So you can see it's ceramic. It's insulated the washer to the win-out hole. This is the win-out. In the middle of the win-out, this is the filament assembly. The filament is basically like this. Okay, here is the win-out hole. It's like a needle, a pinhole in the middle of the win-out cap. So there's a tiny little hole to let the electron to spill out. Now we are looking at another electrode. So this is another insulator. It's insulated the first anode, and they went out the grid. So now this is the first anode. I will mention another thing is it's actually using a negative high voltage to accelerate the electron beam. So I will show you in this paper. In this paper. So here you can see. Now here you can see. I don't know. You can see it. Okay. Here you can see. This is the envelope or the outcase of the electron gun assembly to hold the vacuum. Normally, it's grounded. So the whole assembly is mounted in a metal tube. This whole tube is grounded, and the ground is the negative output high voltage power supply grounded. So basically, the whole envelope or the metal tubing is the anode. So okay. Now this is the first anode we are looking at. Okay, you can see there is a hole. It's not tiny, it's much bigger than the went out hole. This electrode accelerated the electron and being boiled out of the filament. As the electron boiled out of the filament, it passing through the went out hole or the grid. So it's come through the went out hole and the anode. The anode is a negative high voltage. So the electron beam being accelerated by this anode and shooting out of the anode hole. You can see here. And we looking further the next part. Now you can see this 4 hollow metal pipe. This actually has a electrical connection inside like this. So it's ceramic, and in the middle is a stainless steel wire. It's basically connected the deflection plate, so it's making the electron beam to deflect it in this way. Now we are looking at this aluminum made a metal tube. This is actually the condenser lens. So the electron beam being accelerated by the anode and passing through the hole and shooting out into this condenser lens. In this lens, there's a very strong electrical field, and the electron beam can be shooting out in one beam, so it's not passing through anywhere. You know what I mean? So the next part is another insulator. So in this insulator, you can see there's something spotted on the inside wall of this insulator is actually the electron beam causing this. Okay, here is another electrode. This is a focus electrode. So this gun is pretty old. The modern electron gun in scanning electron microscope is actually using a magnetic field to focus the electron beam. So this is the pretty old one. So they are using the electron field, maybe a couple of thousand volts to focus the electron beam. Another thing we can see here, that this part and this part actually are mounted together. You can see they are pretty smooth between the mounting surface. Actually, they are like this. So why they doing like this? It's because the electron field is very high between these two electrodes. If there's another surface get a spark in this, so it will discharge between these two electrodes. So basically this is the focus ring. It's pretty beauty, maybe. Oh, nice. God damn it. Okay, we're moving further. There's another insulator, also made by ceramic. So here is the second anode. This anode got a hole in the middle of it. So actually you can see there's a burn mark inside the metal dish. This is because the electron beam bombarding it for a very long time. Also you can see the inside of this second anode cup. There's some discolor or yellowish color. There's also caused by the electron beam bombarding through this metal. So this is basically built on by the stainless steel. It's not magnetic. Okay, now the last thing we are looking at is the deflection plate. X axis and Y axis. So you can see the insulator between these four metal plates. We are using it. While we are using it, we will apply an electric field between these two electrodes or the metal plate. So the electron beam passing through these two metal plates. If there's a voltage differential between these two metal plates, now we are actually making an electrical field. Then the electron beam can be deflected by the voltage differential between these two plates, negative or positive. The electron beam actually negative charged. So if this be positive, the electron beam will be deflected in this way. If this be the positive charged, the electron beam will be deflected in this way. So in this way, we can create a scan pattern. Okay, So here is the whole assembly of the electron gun. You can see it. Focus, first anode, win-out cap, and the filament. Now I will show you the filament. I'll disassemble this. Unfortunately, this filament is actually dead. I can't measure in any conductivity between these two leads. So I decided to take it apart and see what's going on inside. Okay, we are moving the screw. Oh. Okay, take it out. Easy. So this is a win-out hole or the grid holder. There's not much inside of this. It's pretty well machined by stainless steel. Okay, this is the whole assembly, actual whole assembly of the grid or the win-out cap and the filament. Now these two, actually there are 3 screws, but there's a missing one, so I don't know what happened. Okay, we got the filament out of the win-out cap. Now you can see the win-out cap. This is the win-out cap. This is the win-out hole or the grid. This is the filament. You can see it's a very tiny little V-shape tungsten wire. Maybe I'm using a paper. You can see it much better. So you can see it. Okay, a V-shape, a very sharp end, a filament. Actually, the electron will boil off from the tip of the filament. Now we are seeing the brick part. Oh, it's actually broken. I can see it. You can see it? I can see it. It's actually broken. Not in the tape, not on the tape, or in the middle of the side. Yeah, it's broken. Okay. So this is the whole assembly of the cathode. Yeah, this is actually a type of cathode ray tube. Yeah, or CRT. Yeah. So in next video, I will show you the high voltage power supply. Maybe next month, I think. Yeah, maybe next month I will show you the power supply, how I made a negative output high voltage power supply and adjustable. It can output from 1 kilovolts to 25 kilovolts negative. Yeah, so I've been taking a lot of project and product on this Microscope project. This is actually the turbomolecular pump control board I'm being built myself. It's a pretty weird turbo pump. It's using 4-phase brushless DC motor. I will show you the turbo. This is the turbo I'm been using. So this Pfeiffer. It's a Pfeiffer TPH 110. 110 liters per second. Pretty tiny little turbo molecular pump. So I've been working on this for a few days and it's not preparing good. I think maybe in next video I will show you together with the high voltage power supply. So I hope you enjoyed. I will see you next time. Bye.